All right, welcome back. Now let's start section 5.2. So 5.2, we're going to be talking about one-to-one functions and inverse functions. So inverse functions are really important. They allow us to do something in math that's pretty significant. So before we get into this, we have to talk about one-to-one functions. So one-to-one, what on earth is that? Well, let's find out. So a function is one-to-one if when f of a is equal to f of b, then a is equal to b. So it pretty much is saying, hey, if you plug in a number into the function and get a result, if you get that result repeated, then you have to have plugged in the same answer as you did before. So every time you plug a number into the function, it's going to give you a different answer. And that's going to be true for every one-to-one function. Now, not every function is one-to-one, but there are a lot that are. So how do you tell? Well, one way to tell is to use the horizontal line test. And that determines if a graph is a one-to-one function. Okay, so we're going to do just kind of that. Are the following one-to-one? So example A, you just have a set of points. So in this one, if you look at all of your points here, the answer is going to be no. This is not representative of a one-to-one function. So then the question is, okay, well, why not? Do you see it? There's something in there that says, hey, this is not one-to-one. So there's something in here that your eye should be drawn to, and it's these two things, the 220s, because that's not following your definition. So you should have had two different y values with the two different x values. So that if it wanted a reason why it's not one-to-one, say like y equals 20 has two different x values. So the y values you can repeat as long as its x value is also repeated. That's okay. But if you have the same y value with different x's, that's not one-to-one. Okay, y equals 4x to the third. This one, that's going to be a yes. And this one, you can think of the graph. So it's kind of like that. So if you put a horizontal line anywhere on the curve, if it hits it only one time, no matter where you put it, then it's one-to-one, and this function passes that little test. So for C, x squared, that's going to be a no. So there's your parabola, but if you stuck a horizontal line like right here, it hits it twice. So if it hits it more than once, it's not one-to-one. Okay, so why are we going over one-to-one functions? Well, it's necessary for one-to-one functions to have them or to know what they are, because that's how we've created what an inverse function is. So an inverse function is kind of dependent on that one-to-one function concept. All right, so what is an inverse function? Well, it's a function that reverses another function. And you use it all the time, whether you realize it or not. So like if you had addition, what's the reverse of addition? Subtraction. The reverse of division, multiplication. What's the reverse of like a square root? That would be a power of 2 or an exponent of 2. So we use these inverses all the time to reverse like an actual operation. So that's why they're pretty important. Like there has to be a way to go forwards and then also a way to go backwards. So in order to have an inverse though, the function has to be one-to-one. Also, if f of g of x equals x and g of f of x equals x. So if you do the composite function both ways and you get the same answer of x, then f and g are inverses. And then something else that's kind of cool is if the point xy is a point of f, then y comma x is a point of g. So when you go for the graph of a function to its inverse, you're just flip-flopping the points. Don't like negate the signs or anything, just flip the order. And then the typical notation for an inverse function is that f with that little -1 up there, and that's really important to distinguish from something else because it looks like that little -1 is an exponent. So in this case, it's not. So just remember or note that f inverse of x, it's not an exponent. So usually with negative exponents, they take the reciprocal. So since it's not an exponent in this case, it's not taking the reciprocal of your function. So just don't take your function and flip it over and stick it under a 1. That's not how it's going to go. All right, let's go ahead and stop the video here, and then we'll pick it up in the next one, and we'll talk about inverse function values and actually how to find the actual inverse function.